again, but do fill those out. We've also got a number of our team in expo areas. So if you go into the lobby, and then you can access the expo function, and you'll be able to see our teams from BD, procurement, infrastructure, and talent. So if you want to buy something from us, if you want to sell something to us, if you want to supply us with energy and hydrogen, or you want to come and work for us, this is your time to go and check that out. So either do that during the breaks or in an opportune moment. That'll be open throughout the 2 days. So with that, I want to hand straight over to, we're very fortunate to have Imogen Bhogal as our moderator for the next session. Imogen is a presenter and head of Halo content for Fully Charged, really popular YouTube show. So I'll hand over to Imogen. Please introduce our panelists in the session, please, Imogen.
Oh, fabulous. Thank you so much. I also had the pleasure of seeing the ZeroAvia in flight, which was extremely exciting. So this panel here is about electric propulsion, delivering power and efficiency for fuel cell powered flight. And we've heard already today about innovations in fuel cells and the opportunities and challenges presented by liquid hydrogen. But to reduce the size of the energy density challenge, we need unparalleled levels of efficiency in power delivery and propulsion to get as much from that hydrogen or battery as possible. Multi-megawatt fuel cell systems for aviation are coming, and weight-optimized, hyper-efficient aerospace-ready electric propulsion systems are advancing in support. But what exactly are the limitations on electric propulsion? Where are the big engineering challenges that might put the brakes on motor and power electronics? How can developments be accelerated with the use of digital twins and AI technologies? Big and critically important questions, and here to help answer them are our fabulous set of panelists. We will be joined by Dr. Youcef Abdelli, CTO of Propulsion at ZeroAvia. He has an extensive history in the aviation industry, having worked for Amazon Prime Air, Magniex, Lipas, Safran, and of course Airbus. Peter de Bock, Program Director at ARPA-E, and his particular focus is evaluating untapped moonshot opportunities and developing financial opportunities for ARPA-E hard challenges. Michael Cervenka, CTO at Vertical Aerospace. He also brings over 20 years experience from Rolls-Royce. Professor Sastry Pamidi, Associate Director of Center for Advanced Power Systems, Professor and Chair, FAMU-FSU College of Engineering. Amongst many projects, Sastry is lead researcher in superconducting power applications and cryogenics. And last but by no means least, Russ Dunn, CTO and Head of Strategy at GKN Aerospace, where he was also VP Chief Engineering. So quite a lineup there, and one who will have to forgive me for perhaps my slightly less well-informed questions. So in order to kick us off, I'm going to ask each of the panelists to set the scene by describing some of the challenges, the landscape that currently exists in this particular field, and especially as it relates to each individual's particular area of expertise. So we'll go in the same order that I introduced you in, and Dr. Youcef Abdelli, I hope you can kick us off.
Thank you all. Appreciate the time and the effort to set up all this event. It's great to have the community as well, talking all the the challenges we have, and this is important. So Dr. Youcef, as you said, CTO Propulsion in ZeroAvia, the Seattle based and as well the UK based. We are a multinational company, as you know, and we are addressing the challenges from from the certification perspective with regard to the the both countries, with regard to the CAA and FAA. And our approach is practical and pragmatic. As before we start any design and integration and testing, we are putting the certification as the as the premise, but as well the start for any design rules down the road. So we wanna get it right from the beginning, and as we have seen in the last session of the hydrogen. The issue of the community and the world is the time. It's the feeling we need to put the effort and find the solution and find the suppliers built on the supply chain, which got absolutely distracted by the COVID and all the challenges the world is going to. So from the propulsion system, what we are solving, the big problem by cutting to simple problems, like starting by technology breaks and working on a specific area from the materials to the product to the system integration and all what the plane require to get certified. So a lot of effort there between our teams, but as well a huge connection to our supply chain, a huge commitment from ZeroAvia as well to our supply chain, a partner to not only empower them, but as well invest on them. And this is, I think, the one of the path we believe is the right, because we need to have the commitment for that small big community to achieve our goals.
Thank you. I'm going to ask Peter to also set the scene with some introductory thoughts.
Great, thank you, Imogen. It's very exciting to be here, and congratulations to ZeroAvia for this exciting event. So I work at the Department of Energy at ARPA-E, which is the moonshot agency for Department of Energy to look at next generation technologies that can be transformative and change our energy landscape. Within that capacity, we studied the transportation sector in detail. And one of the things we look at when we look at aviation is that we really need to increase the total efficiency of the aviation platform. If you currently look at going from fuel to thrust, which is propulsion, the efficiency of conversion from pure energy basis is around 35 to 40%. And we've seen that before. It's called combustion engines. And there are ways to do that much more efficiently, and that's called electrification. Now, whether you get the energy from a fuel cell that runs on hydrogen or another fuel, or from a battery system, like we are recently launched Propel 1K as an effort to get to 1,000 watt-hours a kilogram battery systems, or a hybrid of both, it doesn't matter. In the end, we need electrons to break the Carnot limit on our efficiency of propulsion. We can get that to 60 or 70% more efficient. We have a total win for the climate and a total win for economics, because fuel and energy is a large part of the transportation cost. Now, within ARPA-E, we launched a number of programs to improve the integrated propulsion drivetrain to be much more higher in efficiency. These include reach, ascent, cables, Propel 1K. We also launched a program to manage contrails called pre-trails, but I'll focus a little bit on ascent, which focuses on the electrified propulsion drivetrain. If you currently look at jet engines and you look at the power density of a jet engine, you're looking at somewhere between 12 to 15 kilowatts per kilogram of total conversion efficiency that you can get out of a jet engine system. ARPA-E launched the Ascent program to match that efficiency with an integrated propulsion drivetrain running on electrons. And that program is called Ascent. Within Ascent, we have a $63 million program focusing on developing next generation motors that also includes the power electronics as well as the thermal management system. Very important. We often forget that the thermal management of our electrified drivetrain is part of the mass balance as a subsystem to reach greater than 12 kilowatts per kilogram. Now, I'll tell you today, these numbers are probably in the 3 to 5 kilowatts per kilogram. So we're trying to multiply that by 2.5x in a program that's currently in its third year. We funded over 10 teams to tackle this challenge, and that is done from a technical point of view by increasing the electrical loading, magnetic loading, and very effective use of materials. And currently we have 10 teams moving forward with prototypes in the 250 kilowatts to 2 megawatt size that will spin in 2024. Some of them will be tested at altitude in 2024, early 2025, and some of them actually might take flight. So I can tell you with assurance that I see the path of motor and integrated propulsion drivetrain included move forward in its power density by factors that are 2 to 3x. But I do see that the important factor there is to really see it as a subsystem of the motor, the power electronics, and the thermal management system as a whole. And innovation in all of these three areas is what really gets us there. So I look forward to a future of sustainable flight enabled by transformative technologies and developed by teams and adopted by teams such as ZeroAvia.
A win for efficiency and a win for economics. That's a phrase that I'm definitely going to be stealing. So thank you for your thoughts, Peter. On to Michael.
Thanks very much for having me. I think it's a really interesting space, and half of our challenge is the technology, but the other is how do we find routes to market and industrialize, and how do we make a difference? And eVTOLs are perhaps the nearest mass market opportunity for a pure electric aircraft. The aircraft you can see behind me, in fact, we've flown a full-scale prototype, is pure battery powered to start with. And one of the challenges we often get asked is, well, doesn't range become a problem? And we've all dreamed of flying over the traffic. Actually, we've sold conditionally 1,500 aircraft all over the world, North America, South America, Europe, Asia, to some of the top operators like Japan Airlines, American Airlines, Virgin Atlantic. And the majority of initial routes they want to do are actually quite short. So you can fly, probably 50% of the flights for our customers are less than 35 miles, where it's really about hopping over the traffic, connecting airports to surrounding areas, tourism, just where there are gaps in the ground-based transportation infrastructure. So there might be mountains or lakes or whatever. And so there are really useful, commercially viable cases where you can deliver something useful with a battery-powered aircraft today. And battery is only part of the story, because the vehicle behind me looks nothing like an electric helicopter. And so actually we're using that to enable us to distribute the power around the aircraft. And that enables us to do a few clever things. Firstly, we can build in redundancy, and that means safety. So in a helicopter, they're incredible devices, but there are about 60 single point failures, any one of which stops the aircraft continuing to fly. And yet we have multiple motors, multiple batteries, multiple control systems, and so on. So effectively, we're going to certify to the same safety standards as commercial aircraft. We can make the aircraft really quiet. So it's about the noise of a loud conversation in hover and literally the noise of a domestic fridge in cruise. We remove a lot of the maintenance costs that you get with helicopters by having effectively that redundancy and avoiding heavily stressed components. And then, of course, it's zero emissions. So when you bring all this together, I think it creates an opportunity that is really quite disruptive and avoids, it really helps on a near-term challenge. But then the reality is batteries, I'd love to get to 1,000 watt-hours per kilo. We also have really demanding power requirements. You can imagine, I mean, this vehicle is a megawatt plus of power in some of the failure hovering cases. So weight becomes incredibly critical. And so certainly for us, we don't see batteries suddenly enabling you to fly, in our case, a pilot and 4 passengers, many hundreds of miles on an eVTOL. And so the strategy is very much meet the initial market needs with batteries. As batteries get better, inherently that enables us to offer a higher payload, flying faster, perhaps charging more quickly. But then I definitely see parallel tracks where we could go for hybrid solutions, so still using batteries to provide the power boost in hover, but a bit like a hybrid electric car, having a fuel cell or a sustainable aviation fuel-powered ICE engine or gas turbine, providing that range extension. So think of flying from London to Paris rather than, say, London Heathrow to Brighton or some of the surrounding catchment areas. So it's very much a sort of two-step approach, but lots of technology development actually to distribute that amount of power safely around the aircraft and to certify it to standards that do not exist today in aviation as we stand.
I've also been lucky enough to sit in the VX4, but not lucky enough to fly in it. So I hope that could be on my wish list for
come soon.
Yeah. Professor Sastry. Thank you. Oh, I think he might be on mute. Perfect.
Good morning and good afternoon, depending on where you are. Before I start, I want to commend ZeroAvia for putting this event, because one of the challenges is public awareness and getting public support for zero emission aviation. And I think this event achieves that. One of the benefits of this type of events is public awareness. Power density, as discussed already, power density and high efficiency are two critical parameters for achieving zero emission aviation. And there are many ways to get it, but one of the areas that I'm working on is superconducting devices or cryogenically cooled normal devices. As before I go into details, I want to acknowledge ARPA-E funds some of my work, and NASA has been funding my work for a while, and we are part of a university leadership initiative on hydrogen-fueled zero-emission electric aircraft. So either it's superconducting materials or cryogenically cooled hyperconductors, aluminum and other alloys that have very low resistivity at cryogenic temperatures. And they can make the propulsion systems highly efficient and high power dense. And that will make it easier if we can provide the cooling necessary. And as we heard in the previous panel, liquid hydrogen is gaining momentum, and there's a lot of effort and progress in this area. So if we have liquid hydrogen on the aircraft, that makes cooling easier because we can use that as a heat sink. And once we have the cooling available, hyperconductors, that is normal metals that are cooled to very low temperatures to carry a lot of current, are superconducting materials. They carry significantly large currents compared to normal metals, make the whole system efficient and high power dense. As Peter mentioned, and there is no way to avoid power electronics in the chain. So getting high efficient power electronics, integrate them well into propulsion systems is also critical. And cryogenics can benefit in that area if we can develop cryogenic power electronics. Again, there has been significant developments in developing power electronic energy conversion systems operating at cryogenic temperatures. That will make the integration problem a little easier because everything is at cryogenic. Power doesn't have to leave cryogenic environment. These are the two areas, and there is a lot of work in developing low AC loss conductors. ARPA-E, NASA, DOE, everyone has been supporting that. And that will also make it easier to achieve superconducting or hyperconducting power devices, including the energy conversion systems with cryogenic power electronics. And another area of our interest is you can't achieve any of this without having a very well-trained workforce in cryogenic superconducting system, power conversion systems. Being in a university, we focus on training students in liquid hydrogen, generally cryogenics, power conversion systems, superconducting systems. So our work has been in educating people, getting students excited about this zero emission aviation. And generally young people are interested in sustainability and climate change. So we're using this to bring more people into these areas to develop future workforce. I'll stop here and continue with questions.
Okay, that was a wonderful introduction, and I think introduction. Sorry, and I'm afraid to say that I don't think I will ever be able to say that my research is funded by NASA as a journalist. But what a wonderful introduction! Thank you. And last but not least, Russ, been waiting very patiently.
Hi all. You would not believe the challenge I've had to get in front of a camera. Very exciting journey home. Yeah, from a GK and aerospace point of view, I guess our key ambition from the very beginning was all about maximizing the potential payload range that can be achieved for zero emission flight, notwithstanding the fact that there are multiple ingredients, both in terms of aircraft technology and engine technology, let alone all of the infrastructure challenges. But our challenge really has been all about maximizing payload range that zero emissions can be achieved on. And all of our technology, all of our product development, all of our technology development has all been basically driven by that common mission. What we're actually doing is developing technical solutions, first of all, looking at the aircraft level, understanding what the potential requirements for future aircraft will be, and then translating those into specific subsystem component and equipment and associated technology requirements. Where do we start? That starts at the fuel system side. developing both storage and the system requirements for the future aircraft that can support actually both fuel cell and also combustion solutions. But then the most sort of advanced piece of work we've been doing is then in translating that fuel through the power system, through a fuel cell balance of plant, and using in our solution, using the cryogenic liquid hydrogen as a heat sink, actually for an intermediate material, gas, helium, to then cool our cryogenic cool our electrical network and also our motor in order to significantly reduce the losses in the system and hence improve efficiency. So our system is very much about trying to maximize payload range, overcome the challenges that can come through power and hence high voltage as we get to larger and larger aircraft. So ultimately, that's what we're looking to achieve. We are taking our ground test of our power system completion by end of 2025, with an ambition then to take that further into flight and validate the technology for flight over the next 2 or 3 years after that. So that's probably everything I was going to say at the beginning. That's our sort of key areas of focus.
Thanks, Russ. And you made it with perfect timing, so no need to panic at all. What scene set?
I literally just ran in.
Well, you know, you've made it. You can relax. Hopefully, the next questions won't catch you out too much. But I think we've set the scene there, and a few themes that have emerged. We've got obviously things around power density, energy density, dealing with cooling, power distribution, public awareness, supply chain and suppliers, that community that need to be within this broader ecosystem, maximizing payload and range, and of course, skills. But one of the things that really strikes me is that in this whole afternoon, we've spoken about a huge range of different solutions and lots of hybrid solutions. You know, we've got things on cryogenic, liquid hydrogen, turboelectric generators, solid oxide fuel cells, various other hybrid systems, and battery electric. Ooh, I'm just going to move that poll, sorry. So is the focus too broad? Has that created too much complexity? And does that ultimately prevent us reaching targets set out by 2050 and slow down potentially the rate of innovation? And I wonder if, Peter, you have a number of different projects, perhaps you're best place to kick us off.
So that's a great question, Imogen. The way to look at it is within the portfolio of 10 teams, I have many different solutions, probably all of those that you mentioned. There are some that are air-cooled at 12 kilowatts per kilogram and some that are superconducting and anything in between. We have supercritical CO2-cooled machines, we have liquid-cooled, all kinds of different mechanisms. And the way I see this, Imogen, is that there are many different missions. So for a short-haul mission, you want to have a simple system that can do something very efficiently, but it's mostly a simple system. And I think what you see is that the breadth of technologies all fit their own different aircraft space. In my mind, in the short haul, and I could call short haul, you know, even beyond London to Paris. That was mentioned by Michael. I would love to go London to Barcelona. Or we actually have a pathway that we are trying to fund all the way for a 100-person aircraft to go 700 miles, which is 1,000 kilometers, maybe London to southern Spain, on fully electric, battery electric, or that's the kind of technologies we are currently supporting through ARPA-E. Anything beyond that, which is still a lot of flights, you know, I think that bottom segment might be as much as 20 to 25%, will require fuel cells, will require hybrid systems. And anything where we go, you know, let's say from London to Sydney or London to South Africa, we will need something more on the full hydrogen system side, maybe with the superconducting systems. So what you're seeing is really emerging is that there are different solutions for different segments of the aerospace sector. And that might be a different way to look at it. Currently, we often think about the narrow body aircraft or wide body aircraft. The narrow body aircraft right now can do a very wide range of missions. It can fly 1 hour, can fly also 10 hours. So I think we really need to think about, not think about the current aircraft as we know, really think about the missions that they fulfill. I think then you see this broad spectrum of solutions emerge that each have their own space of viability.
That's really interesting, and I think makes complete sense that we're looking at a broader range of different use cases, and that, as you mentioned, is going to determine the specific technologies that are employed. But many of those use cases are looking at the shorter flights, the sub-regional sort of use cases. And in that instance, I guess largely driven by regulation, we've seen a lot of retrofitting of technology. Does that compromise the efficiency that you're able to reach? And Michael, I know that for you, you've had a slightly different set of challenges because you've had perhaps a more blank piece of paper approach. And actually, Dr. Youcef, I'll come to you you can kick us off, because I know that for ZeroAvia in particular, it is, of course, a retrofit.
Yeah, that's a good question. Yeah, it's all what we do is the focus and how we can get, to 2025. And of course, beyond. So we are addressing, the retrofit market, but the lean market as well, lean retrofit. So with we look to the market and where we're going to put that technology to enable as well, our customers, and we start putting that technology in the air and gathering the hours, right? By the end of the day, we prove the technology through different processes, whatever that processes are, from the maturity level in terms of technology, but as well in terms of manufacturing level as well. And we found out that we can progress in the technology as much as we can by putting the investments, the team. The supply chain is still behind, because we need to tell a whole story about our program, our project, our vision, mission, but we need to ensure as well the supply chain. And we found out after that timing, we are facing different issues from the supply chain trust, even to put money and put their investment in something they need to see they need to see the end of the tunnel, right? And put the investment and put the team. Some of the suppliers, they are 5 people. Some of the people, they are 20. Some of them, they are big. And when they start to be big, medium, whatever, why I need to believe on this. So we have as a community to come with a pragmatic solution. So we started by talking about what are the market today with regard to the short distance, medium distance, long distance. How many aircraft from the Dunn to Cessna to King Air to all of them? What's the next level, which is the ATR and the Dash 8? What's the next level? More. But when more we go, more we are saying we have to put the technology we are designing and producing today in a platform, and we gather the data from that from the customer perspective. With the Dunn and the Piper, we have learned a lot. I think the data we have today, it's a tremendous input for the entire community in terms of how we deal with the hydrogen, how we convert the electricity, how we convert the hydrogen to electricity, and how we deal with the control and the safety strategy, safety aspect on this. The next, I think, milestone for ZeroAvia is after the successful 10 flight with the Dunn, we're gonna put our design in-house technology for the next year, and start as well putting the limit and gathering minute by minute, hour by hour, the timing, which is relevant to certain level of distances. And we cannot solve the entire issues and problems. We are tackling the issues by let's make the feasibility study first, and after that create a requirement, generate a requirement in-house, get the engineering and the supply chain and production working all together, designing the product, go to certain level of qualification, put that in flight, coming back and iterate on this. So we are more in iterative process. We believe is the pragmatic way. We are not following any book, to be honest with you. Just our instinct to make it right with regard to the standard processes from the system engineering processes, and of course, like, you know, how we get that in the in the air. Our biggest, you know, challenge is I think is not the technology by itself. It's more the supply chain, and I'm insisting on this because more we go, the more we are getting to that, you know, transparency and trust from the supply chain to make sure that if I follow you, we're gonna share that market, you know, one day. And this is like, you know, as a community, we need to work on this to create that confidence.
And Michael, how does that challenge differ in your sphere, whereby you're creating a brand new market, essentially? You have that blank piece of paper approach. Has that enabled you to innovate more quickly, or how has that challenge differed?
So I think one of the pluses is it gives us control in terms of route to market. And for the kind of aircraft we're doing, you couldn't offer those disruptive improvements through a retrofit. One of the things, therefore, is actually, I mean, Peter talked about different solutions for different markets. I think it's also worth thinking about this in terms of building blocks and how we deliver technology and supply chain industrialization, and also particularly regulations. So the fact that we're able to do this on a battery-powered aircraft, Russ is, you know, GKN's one of many companies that is working with Vertical. We're leveraging a lot of aerospace existing technologies, but also building on them where we need things that are different. So we don't want to reinvent the wheel. There's huge capabilities out there. Actually, in many cases, we offer companies a route to market this decade for new tech when Airbus and Boeing aren't going to do a next generation aircraft this decade. So I think there's sort of that element to it. Specific to Vertical, we've invested very heavily in the battery system. So we have a team of about 50 battery engineers. We have the UK's leading battery aerospace development capability. We actually chair the European working group that has been defining all of the regulatory standards for a category enhanced battery system. So this is, if you look today, there is only one certified pure electric aircraft, which is a trainer electric aircraft that does not have the kind of safety standards you'd expect for large scale commercial flight. And we've actually had 6 out of the 9 means of compliance standards agreed through EASA through that. So I think there are lots of building block technologies in terms of, you know, 800-volt distribution, lightweight battery systems that can manage crashworthiness, thermal runaway, all the kind of aerospace safety elements. Doing that in a product that, you know, offers a real commercial opportunity, doesn't require a huge hydrogen infrastructure on day one, so we can start deploying it in sensible volumes, and then provides many of those technological and regulatory building blocks from which we can start growing to bigger and longer range aircraft.
And you mentioned there that, you know, the building blocks, there's a lot of expertise that already exists within the industry that obviously you're pulling together. It's not reinventing the wheel. But Sastry, you mentioned that there is a bit of a skills gap and that perhaps that kind of pipeline talent isn't coming in. What are the sort of specific challenges there? And what is it that concerns you on that front?
I think the first challenge is keeping, yes, I agree with all the panelists that we need to keep developing technologies for all sectors of the market and all segments, but we need to paint a picture of zero emission aviation for the whole aircraft industry. I think that is important to get young people excited and get into the field, develop new technologies. So we are paving the way, but we need a lot of young people engaged in this area. Unless we show a promise of zero aviation across all sectors, all types of aircrafts, I think we will miss the target. So I think developing slowly, step by step, small aircraft first, and at the end, intercontinental aircrafts with hydrogen. We need to have all the technologies and show people that we have a solution for every sector of the market. I think getting young people engaged and train them, the skill gap is important. We don't have enough people in these areas because it's new, and getting university students excited and getting into these areas and getting into small businesses and entrepreneurs getting more and more investment into this area is important. I think public awareness and getting young people involved is the key in my view.
If I can just add, I think there's a real cross-sector bit to this. So our battery team is almost entirely automotive, from Jaguar Land Rover, Dyson, former head of the batteries for the European Space Agency, and you mix those with aerospace people. So part of how we address the skills gap, I think, is thinking about this from a cross-sector perspective. And then exactly as Sastry just said, some of it is we have to grow that capability. You can't go and today hire a battery team who have certified these kind of systems before, similarly hydrogen. So definitely some of that is how do we bring in skills from different sectors, but then also give them really exciting, tough challenges, which engineers love, and get them to kind of see the opportunity space.
Yeah, there's one thing I think we did not address is you asked about AI and machine learning. I think those tools are extremely important to ensure safety. So I think we need to get AI involved in understanding the condition of the equipment on the flight and make sure everything is safe. I think AI can play a big role in safety of the systems.
Can I just add a comment to Michael? Sorry. I mean, a lot of us sort of ground our teeth on big programs in our past. You know, I spent 17 years at Airbus developing A380 and 350. A lot of people of our generation have had the opportunity to really prove and learn and fail through the application of knowledge into big, important, challenging aircraft development programs. And I know Michael, from a Rolls background, had some similar ingredients. I think it's really important that we also develop the next generation of people through the next generation of development programs. And some of them have got a real challenge because some of them would have graduated just at the end of those big last programs and have got, you know, potentially a 10 to 15 year gap before something really big happens. And that's why I applaud, you know, the Verticals and the ZeroAvias and others who are really pushing the pace of new product development, because that's how we're going to sort of hone some of those skills. What we're doing is a slightly different glide path, as I mentioned earlier on. But I do think it's really important to get people to think and apply their knowledge and develop their skills on real programs that are pushing aircraft to the next step.
We have heard some amazing things there, and I'm really conscious that we're coming towards the end of this panel. But I think the fact that, you know, this can be a completely multidisciplinary space, pushing that sort of glide path, as you mentioned, that transforms this into an hugely exciting area. And a shameless plug that on the Fully Charged show, we do have lots of engaging videos to share with younger people who are perhaps interested in entering into this space. So I'm going to ask you one last question, and if you can make this as quick as possible. We've addressed and outlined some of the challenges that exist in this sector and towards getting higher power density and energy density. However, we are also approaching Christmas. So if you could have one Christmas wish for something that would make your life infinitely easier in pushing through developments at the rate which you would ideally have them happen, what would be your one Christmas or holiday wish? And I realize I should have warned you that I was going to ask you that question. So apologies for that, but at least we'll get the spontaneous answer. Anyone feeling brave?
I'll dare to go first. I'm going to give a couple. Funding is always a challenge when you're a startup and trying to do things at pace with innovation. I think we've got a huge opportunity in the UK to leverage a lot of capabilities. I think it's how do we join up technology development through to industrialization and scale. And the UK is amazing at doing innovation and doing research. It is not always quite so successful in leveraging that all the way through to being a world leader in many areas. So aerospace has a track record of doing that. How do we harness all these capabilities to really, you know, play on a global stage and break the way, you know, the sort of barriers between innovation on the one hand and scale up on the other?
Yeah, my wish is we have a lot of momentum. I wish we continue this momentum until we see zero emission aircraft across all sectors. Maintaining the momentum is my wish.
I have two wishes. Is that okay?
That is absolutely fine. We can make allowance.
So one, I like fuel cells to be more efficient. So the heat losses kind of worry me sometimes on the PEM side, and SOCs kind of seem to be orphaned without a gas turbine hooked up. So really efficient fuel cells in the 70-80 range. This is very hard. we got to do it. The second part would be, I would love for my 1,000 watt-hour kilogram battery to be here tomorrow. It's probably going to take another 10 years, but we started the program on it. So I do have the opportunity that I'm in the position where I can fund my wishes. So we funded Propel 1K to help the aerospace sector electrify more.
We'll happily take it when it's available.
So if I can add also two, the first one would absolutely be, we've got some big collaborations which we're nearing getting to the point of announcement, getting those over the line, because we've got some fantastic partners waiting in the wings, getting ready to take the next step with us. So getting those secured and celebrating and moving forward on those would be fantastic. The second one, just being really open with you, the most complex part of what we're developing is our cryogenically cooled electric motor. Getting our first test of that done and demonstrating all of the complex analysis that's gone into the development of that technology, getting it tested and proving that it actually delivers how we expect it to deliver, that would be just an amazing present, because it's such an important piece of our jigsaw.
And last but not least.
Yeah, I have one wish with a lot of people working on different technologies, but aiming to the same purpose and mission. And I would love, a lot of people like GKN, Vertical Aerospace, Peter and ARPA and Florida universities get all together and discuss about, some not wasting time and money, individually, but collectively in some, open ideas and, sharing data and all the stuff, to get quickly, faster to what is really late, what we want, to achieve, because it's not just only business. It's a big problem we are facing for our next generation. And if we continue to work separately as we are, it's we're gonna get tired when we get and when we achieve the stuff. So I think we can help each other with even putting the patent all together, getting together, sharing data, sharing laboratory, sharing stuff, and that's going to be the one of the wish I ask the team to do it, but as well the community as well.
Well, I think that is an absolutely fantastic note to end on. So thank you so much for your contributions to this panel. And yeah, thank you very much.
Thank you. I appreciate it.
Thank you.
Thank you. And
thanks, Imogen, and thanks everybody to all the panelists who joined. Really great stuff. We've run slightly over, which is totally fine. Fascinating conversation. We obviously had a number of panelists on that one, so well marshaled.